The underlying principle of acid-base titration is to determine the volume of acid use. Let's look at different apparatus that you can use for volumetry analysis. You must have heard of burettes. We have pipette. We have beaker. We have funnel. We have chronicle flask. We have white tie. We have wash bottle. We have distilled water. So you will know that when you look at these apparatus, you can classify them into two. You have the one that has to do with solution. You have the one that has to do with solid materials. All these burette and these, and they are mostly for measurements. So looking at this titration, you have the acid put into the burette, and you have the base pipette into the chronicle flask. And one other thing that you add to the chronicle flask is indicator. And what is the essence of indicator? Indicator, looking at pH indicator, is used to monitor the progress of the acid-base reaction. What does that mean? If you fail to put indicator or add indicator together with the base in the chronicle flask, it might not give you the correct neutralization. So looking at the pH, a pH indicator is made from the weak organic dyes, and we have indicator that you use it for strong reactions between acid and base. You also have indicator that is used for strong reaction with weak reaction in this acid reaction. Now, look at this. A suitable pH indicator must be chosen in order to detect the end point of the titration. The color change or other effects should occur close to the equivalent point. Now, when you put your acid in a burette run from 0 to 50 downward. Your pipette, we have two types of pipette. We have 20 cm3 or 25 cm3. But as far as model is concerned, we have 25 cm3 pipette. And when you use 25 cm3 pipette, you don't record 20 cm3, because we are still going to look at how do we record acid-base titration. So now when you pipette your base in a chronicle flask and you add indicator, you run your acid, you gradually run your acid, it gets to a point the color changes. Now, when it gets to the point that the color changes, you reduce the flow of the acid until the color permanently changes. So the point at which color changes is known as equivalent points. You can as well call it end point. You can as well call it neutralization points. You can as well call it neutralization points.